Hello, Algebra students. We are discussing completing the square. This is section 4.7, and a prerequisite skill that we have to know in order to complete the square properly is how to solve equations that look like this. So in this problem, we're obviously trying to solve for x. We have x minus 4 is being squared, and that's equal to 25. Remember, the first thing that you would do in a problem like this is get the thing that you're trying to square by itself. And we do have x minus 4 is the thing that's being squared. It's by itself. So now, in order to get rid of the square, we take the square root of both sides. We would end up with x minus 4 is equal to, remember, when you take the square root of both sides, you get plus or minus 5. And then from here, you would just add 4 to each side, and you would have x by itself. That's our goal. When you add 4 to positive 5, you would get a 9. And then you would add a 4 to negative 5, and you would get negative 1. So your answers here are 9 and negative 1. And you could verify this really easily. If you plug 9 into x here, 9 minus 4 is obviously 5, and 5 squared is 25. You could do the same thing with negative 1. Plug in negative 1 minus 4 is negative 5, and negative 5 times negative 5 is also 25. So this is a prerequisite skill for completing the square. This is really the foundation of why completing the square works. We have a problem on the left here and a problem on the right here. This is also still review. If I told you guys to solve this equation, you would be able to factor this, right? You would be able to say, hey, what multiplies to negative 9 that adds to negative 8? And you would hopefully come up with negative 9 and 1. So when we factor this, it would look like x minus 9 and x plus 1. And then we would use the zero product property. Remember, the zero product property says if you have A and you multiply by B and you get 0, then either A must be 0 or B must be 0, right? If two things multiply to 0, one of them had to have been 0. There's no other way to do that. So then we can just ask ourselves, what makes this parentheses 0? And that would be 9. We can ask ourselves, what makes this parentheses 0? And that would be negative 1. Now, it's not a coincidence that these answers, 9 and negative 1, are the same answers that we got here, 9 and negative 1. These are actually the same equation. What we're going to be using is just different methods to solve these equations. And this here is also the same equation. I could make you believe that simply by subtracting 25 here. By subtracting 25 on both sides, I would have x squared minus 8x minus 9 is equal to 0, the exact same thing on the left here. Okay, so whenever I've told you guys to factor in the past, like we did here, where we broke it up into two parentheses, it's always been required that this is set equal to 0. It literally doesn't work unless you're factoring when it's set equal to 0, except when you are completing the square. And completing the square is obviously today's topic, and what you are going to do in these problems is you are going to factor when it's not set equal to 0, when it's going to be set equal to something else. And I'll show you how to get that in future slides. But what you're going to do is you're still going to factor the left side here. You would say what multiplies to 16 that adds to negative 8, and that would be negative 4 and negative 4. Right? Negative 4 times negative 4 is 16, and negative 4 plus negative 4 is negative 8. So you might be tempted to write it like this, x minus 4 times x minus 4, except we don't really like that. We like this. X minus 4 squared is equal to 25. Now, I would love it if this was hitting a light bulb in your head right here. X minus 4 squared is equal to 25, because that's what we had here. X minus 4 squared is equal to 25. So now I've shown you that the statement over on the right side is the same as the statement on the first page. And I already showed you that these two are the same. So now I do probably have you convinced that they are all the same equation. You would take the square root of both sides, and then, you'd have x minus 4 is equal to plus or minus 5, and then you'd add 4, and you would get x is equal to 9 and negative 1. So this is all prerequisite skill. If you know all this stuff, I think you're going to do really well with completing this square. Here's the idea behind completing the square. We can write any quadratic expression as long as the a term is 1. Completing the square only works if the a term is 1. If the a term is not 1, you're going to have to use a different method. You can write any quadratic expression, as long as a is 1, as a perfect square trinomial. What does that mean? Well, we were able to factor this statement into a perfect square, right? This statement factored into a perfect square. That's what we're going to be looking to do consistently. We're going to be looking to factor our statements into something squared. We have the exact same number here, -4, -4. That's always going to be the case with completing the square. We can do that as long as the c term is equal to half of b squared. So what we're going to do is we are going to make the c term equal to half of the b term squared, and then we're going to do this process just like we did over here, where you take the square root of both sides and then you can solve it. This is true for this problem here. The c term, right? The c term is 16, and the b term is -8. It is true because I know it factored into something squared. So that means that the c term, the 16, must be half of the b term. So take half of the b term, that would be -4, and then square -4. -4 times -4 is 16. So that's why this worked, to factor it into a perfect square and then solve it from there. So you're only ever going to use completing the square if you can first make the c term equal to half of this, -8, half of it, squared. Every other time when you factor, I need you to have the other side equal to 0. But when you're using this completing the square method, what you're going to do is you're going to have this side be changed to allow the c term to be half of the b term squared. Let's just kind of practice picking the c term, right? We want the c term to always be half of the b term squared. So what you do is you would just take half of the b term. Half of the b term would be -6, and then -6 times 6, -6 times -6 would be 36. So in order for us to complete the square here, the c term would need to be 36. We could continue with this. What does the c term need to be in this problem? Well, you would take half of the b term, 4.5, and then you would have to square 4.5. 4.5 times 4.5 is 20.25. So in this problem, the c term would have to be 20.25. So at this point, I would love it if you were saying, well, sure, that's what the c term would be, but I can't just pick any c term. I have to somehow, make it still true. And that's exactly right? We can't just say, hey, input any c term we want here. But we do have a trick for this. I'll just say that until we get to the actual problem. So let's actually try to complete the square here. The c term that we want is not 4. Right? We want a different c term. Actually, I should be able to ask you what c term we want, and you should be able to come up with that we want the c term to be 36. Right? That's what we want it to be. How did I get that? I took half of the b term. The b term is now -12. So I took half of that, and that would be -6, and then -6 times -6 would be 36. The c term is not what I want it to be, so I'm just going to move this current c term to the other side. So then I would have x squared minus 12x. I'm going to leave a space there because I know I'm going to pick the c term in a second here, is equal to -4. Okay, so I want the c term to be 36. And I can pick the c term as long as what I do to one side, I do to the other side. Because if I add 36 here and I add 36 here, I haven't changed the validity of the statement. I've done the same thing to the left as I have done to the right. The right side here would equal 32. And now I'm going to factor this statement. And at first, you're probably going to go through the steps. You're going to be like, okay, well, what multiplies to 36 that adds to -12? And eventually you come up with -6 and -6, which is true. But what I'm going to tell you is, if you're picking the c term like we did here, remember, we picked it to be something deliberate, something very intentional. If you pick the c term, it's always just going to be half of the b term. It's also always going to be the square root of the c term. Okay? That's just the way it's going to work, because you deliberately picked a very specific c term. So this is going to factor into x minus 6 squared is equal to 32. Now we go through the steps. We take the square root of both sides, and you get x minus 6 is equal to plus or minus the square root of 32. Now, you're going to have to be good at simplifying the square roots here. Okay? If you don't remember how to do that, you need to revisit section 4.5, the lecture on 4.5. It's on simplifying square roots. Remember, what you do is you think of the perfect square factors, 1, 4, 9, 16, 25, etc. And you say, do any of these numbers, are any of these numbers factors of 32? And you should come up with 16, plus or minus root 16, and 16 times what? 2, right? These two things multiply to 32 still, and 16 is the biggest number in this infinite list. That is a factor of 32. So you'd have x minus 6 is equal to plus or minus 4 root 2, because the square root of 16 is 4. And now you'd add 6 to both sides, and we're actually going to put this positive 6 in front right there. So it'd be x is equal to 6 plus or minus 4 root 2, and that would be your answer. Now, it would be a very smart question for you to ask if you're like, well, why would I ever complete the square? You already showed us on this slide that I could have just factored it and got 9 and negative 1. But then you showed us that this is the exact same expression, and you did a bunch more work to solve it over on the right here. So why do we even complete the square? Well, not every problem is factorable. If I actually ever give you a question, like a homework question or a quiz question that's factorable, I have to be very intentional about picking the b and the c term to make it work, because a lot of questions aren't factorable. For example, the one we just solved is not factorable. If you were to list the factors of the c term, 4, you would just get 1 and 4 and 2 and 2. There's no way that any of these numbers are adding to negative 12, right? So this is an expression this is an equation that's not factorable. Factoring only works if your answers are rational, okay? If they could have been written as a fraction. But our answer in this problem was irrational. It's got the square root of 2 in it. So therefore, completing the square can solve problems that factoring cannot. Factoring also would have never given us an imaginary answer. But completing the square is going to be able to give us imaginary answers. In fact, the only time that completing the square isn't going to work well for us, remember, is if the a term is not 1. If the a term was like 3 here, then completing the square, we're not going to bother with completing the square. It could still work, but it's super messy, lots of decimals. So instead, what we do is we actually have a different method that we're going to learn in the next section, section 4.8, for those problems where the number in front of x squared is a different number. Let's try another one. Might be a good idea for you to pause it and try this on your own. Remember, you want to pick the c term. Right now it's 8, and pretty much every problem is not going to have the right c term. So you're just going to move the 8 to the other side by subtracting 8. X squared minus 10x, leave a blank spot, is equal to negative 8. Remember, we're going to pick the c term, and we pick it to be something very deliberate. We pick it to be half of the b term squared. So half of the b term is negative 5, and negative 5 times negative 5 is positive 25. But if I add it to one side, I have to add it to the other. Now here my right side is just 17. And my left side is going to factor, and you can very much go through the steps and try to think of what multiplies to 25 that adds to negative 10. However, I'm telling you that it's always going to be half of the b term squared, right? It's negative 5 and negative 5 here, because those things multiply to 25, and those things add to negative 10. From here, you square root both sides, and you get x minus 5 is equal to positive or negative root 17. And then you would add 5 to both sides, and you would get x is equal to 5 plus or minus root 17. Now, you would try to simplify the square root of 17 if you could. But if we listed those factors again, 1, 4, 9, 16, etc., none of these numbers are factors of 17, except for 1, and we never use 1 because that doesn't actually change it. Right? If I tried to simplify root 17 with root 17 and root 1, well, root 1 is just 1, which is just root 17, because anything times 1 it didn't do anything, right? It just got us back to where we started. So we don't even bother with 1. But any of these other numbers are not factors of 17, so we just have to move up. Now in this problem, I already told you that the a term has to be 1 and the a term isn't 1 here. However, this problem is still doable with completing the square simply because you'll notice that this one has a 2 in front of it. So what I could do is I could just divide everything by 2, and that doesn't change the equation. So if I divide everything by 2, x squared plus 4x plus 9 is equal to 0. Now this equation and this equation, the top one in black, are going to have the exact same answer. And I was able to do that just because they were all divisible by 2, and so it didn't create any fractions. If I had tried that on a previous example, remember I wrote an example up here where I put like a 3 in front here. If I had tried to divide this by 3, it would have caused at least one fraction, and that just changes everything, makes it a lot more work. So we don't do that. But in our problem that we're trying to do, everything divided by 2. So now let's go ahead and try this again. Why don't you guys pause it here and try it. Remember, you want to pick the c term. It's not what I want it to be. So it's going to be x squared plus 4x is equal to negative 9. Now I'm going to pick the c term to be half of the b, and the b is currently 4, so half that would be 2, and square 2, that would also be 4. If I do it to one side, I have to do it to the other. The right side is going to be negative 5. And the left side, what multiplies to 4 that adds to 4? It would be 2 and 2, right? 2 times 2 is 4, and 2 plus 2 is 4. Also note, it's half of the b term. So x plus 2 squared. From here, if you take the square root of both sides, and we got something weird going on, we have the square root of a negative number. Remember, to simplify the square root of a negative number, this would be the same as the square root of 5 and the square root of negative 1. And we know by definition that the square root of negative 1 is equal to I. So the square root of negative 5 is just going to be I plus or minus I root 5, right? Because this one is equal to I, and the square root of 5 can't be simplified, so it's just these two things. We like to write the I in front of the root because it's hard to tell how long this root goes, right? When we're x isn't by itself yet, we have to subtract 2, and we like to write that subtract 2 in front, so it'd be negative 2 plus or minus I root 5, and that's my final answer. So this has been a lecture on completing a square, which is in section 4.7. Please look at some practice problems for this. Make sure that you know what you are doing, and let me know if you guys have any questions.